Hi, I'm Max Clark. Common conversation I get into with customers is how to save money on their cloud bills. Now, there's a lot of horrible terms. A lot of people call these things hyperscalers now. When I say cloud, I'm really talking about AWS, Azure, GCP, go down that list. So we'll just make this really simple, and we'll talk about AWS. Since they're the largest, most people have them, I can keep the terminology straight in my head. So how do you save money on your AWS bill? Oh boy, well, that just opened up a whole can of worms. It depends. You thought this was going to be easy. I was going to give you some secret message. And it depends on everything. It depends if you have written your application. It depends if you have time with your engineering teams to modify your applications. It depends on if you did a lift and shift. It depends on, it just depends. So let's talk about some of these it depends items. I'm going to try to bucket these things into things you can do if your engineering team has time to do them, and things that you can do if your engineering team does not have time to do them, and what's common and kind of pros and cons of these things. And there's no particular order in this. I'm just going to kind of go off the cuff here and talk about it. One of the most common things you hear will be an EDP. And an EDP is a contract that you sign with AWS. It has really three components of it that you're going to negotiate. First one being term length. They're usually 3 years. Second one is revenue commitment. What you're committing to AWS under that term. There's usually an escalation of spend. If you, for year one, you're at $1 million, year two, you're going to be at 1.2, year three, you're going to be at 1.4, right? There's going to be some sort of escalation or growth within that EDP in order for AWS to give you that discount with that EDP. You're going to have support. The default is AWS is going to tell you have to sign up for enterprise support, and what you're going to negotiate in terms of that rate. This is something that makes me crazy with EDPs. Companies that sign an EDP thinking they're getting a great deal. Hey, look, we just saved 10% on our AWS bill. Oh, by the way, we have a 10% support cost that we now have to factor into it. So did you save money? Oh, and guess what? We're committed to grow 130% over the next 3 years with AWS. So whoops. Support. I still see EDPs that do not have support in them. It is not a usual thing. If you're in a process and you're getting an EDP or have an EDP and you do not have support in it, you should start thinking about budgeting on your renewal when you're doing this projection with your teams of adding 10% on support. It will save you a lot of pain and heartache if that gets forced on you. And look, the name of the game used to be that you would threaten AWS that you're going to go to Google, and maybe they would give you better terms, and your mileage may vary on that. The last part of the EDP is PPAs and the private pricing agreements and or addendums, and these are things like negotiating discounts for your egress, direct connects, managed services components, basically everything that bills you within AWS. If you've got enough volume and leverage, you can talk about. EDP is a mechanism that can be imposed without engineering time and resources. So it's I don't want to call it an easy button because it is like heroin. The first hit's free, but then after that, you're going to spiral down into the abyss very quickly and find yourself trapped in the EDP terms. And what I mean trapped is, as you try to save more money, the EDP requires you to spend more money, and you kind of get squeezed in between those two realities. You can't save money in your AWS bill if you're also required to spend more money in your AWS bill. And then you were going to start looking for other things that you could aggressively shift into AWS, including how do you spend money via AWS's marketplace. And by the way, that eliminates direct pricing agreements and discounts with those service providers because now you have to buy through the marketplace, and AWS will probably only give you 25% spend retirement. So if you spend, $100,000 a month on Datadog, AWS is going to credit you 25K of that on your EDP. But EDPs are popular because the finance team or the executive team, people can do them without having to talk about engineering time. Next one is RIs, reserved instances. RIs come in lots of different flavors. You've got convertible and non-convertible instances. You've got different lengths. What seems like really easy becomes really complicated really quickly. And what an RI, you've got upfront or non-upfront payments as well. Again, with an RI is you're making a financial commitment to AWS for a set amount of time, and in exchange for that, you get a discount. Think of it like instead of Amazon making 200% or 300% on the cost of their equipment in their data center, they're going to give you a discount and only charge you 150%, and but you have to pay them for 3 years. Some math kind of like that. Who knows what the actual math is, but that's just how you can think about it. RIs, again, can be great because you can do it without engineering time. How many instances do we have in our fleet? Fantastic. Let's go out and buy RIs and lower the cost in some of them. What gets scary with RIs is trying to figure out, is your application going to be static inside of that environment for that span of time? If you're going to buy an RI and you're going to buy it for 3 years, is your application not changing for 3 years? is your capacity fixed for 3 years? Are you never going to have less capacity or need a different RI or all these different things? Now there's RI marketplaces and there's convertible instances and there's different strategies around how to deal with RIs, but RIs get really scary from that standpoint of trying to figure out how to gauge and size your RI need and commitment. Remember, the whole point of the cloud is it's supposed to be elastic, right? It's supposed to grow up with you and it's supposed to shrink down with you. And RIs, just like EDPs with spend commitments, become very inelastic in nature. So if you have an application that has steady state, probably not a great application to have in the cloud in the first place, but we'll come back to that. Okay, so you have RIs. You have savings plans. Savings plans are a method, again, non-engineering related method that your finance team can go and can commit to writing a check to AWS, and in exchange for writing a very big check to AWS, they will give you a discount on your services. By the way, RIs and savings plans do not apply universally across everything inside of your AWS environment. So you need to make sure what you're actually running will apply to a discount with an RI or a savings plans. There's some cool things you can do with savings plans that are really easy. There's some interesting partners in the market that'll help you offset the upfront purchase of it, so that way you're not writing a huge check and you're still rationalizing some savings out of it. And will help you size the RI, will help you, size the savings plan, or figure out what you'd actually save in the savings plans. Are you running EC2 or managed service on top of EC2 or ECS or EKS or any of these things, and how does that actually apply based on what you're actually running? It depends. Spot's a really interesting animal. And if you've got a application that can auto scale up and down and needs capacity, it could be, let's call it relatively predictably needs capacity. Spot is it's just a financial technique that AWS created to be able to sell, underutilized resources within compute at a lower rate to try to stimulate consumption, right? So if you've got an instance sitting idle, you can sell that, or you can an RI with a commitment, you can do on demand, or you can do Spot. And the idea with Spot is instead of having it just sitting idle and not making any revenue for them, they can sell it at let's call it a lower margin, because they're not selling it at a negative. They can sell it for a lower margin to you. Now the negatives of Spot, so the good things with Spot is you can save a ton of money, hashtag if your application supports it. The bad things with Spot is as soon as a customer comes along and wants an on-demand instance or needs an RI, aka is going to pay Amazon more money than you're paying them in Spot, guess where that comes from? Turn off Spot instances. You then need tooling to deal with that. And now AWS has been adding more and more functionality into their Spot fleet. And then there's third parties that try to give you some signals and information. So like before, let's just say you've got, 500 instances of EC2 running in Spot. It'd be a little disruptive if all 500 were turned off on you at the same exact instant without you, creating any other capacity into your environment. And so there's mechanisms to actually try to predict when those events are going to occur. They're not great. They're better than nothing. And then backfill that with on-demand instances. That way you don't have a performance hit to your application or other bad things happen to you. So then you've got, so Spot. This one I kind of put in between needing engineering resources and time and not. And this is the AWS managed services within AWS. And so if you take what's a great one, let's talk about RDS and Kinesis. Those are my two favorites. So what is Kinesis? Kinesis is AWS's black box managed Kafka environment for you. EKS is Amazon's black box managed Kubernetes for you. RDS is Amazon's black box managed database service for you. They're all great services. Amazon has done a phenomenal job with these things. AWS managed services. Kinesis is awesome. RDS is awesome. EKS is awesome, right? If you don't have the tooling or team or wherewithal to manage these things yourself, you can just go and click in the console or go fire off the API and go boom, 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 click, 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 and boom, you've got it, right? Now, for that black box managed service, gift wrap thing, you're paying a premium. And as your environment grows, and as your, what would we see in an environment, right? So let's say you're spending $2 million a month on Amazon. You're spending $800K a month on EC2 or EC2 derivatives, and then you're probably spending, $200,000-$400,000 a month on Kinesis. That's kind of usual typical math, right? So maybe 10% of your AWS spend on Kinesis. in an application. Maybe higher, maybe lower, but let's just call it 10%. There's a lot of overhead and waste in that bill. So $200,000 a month in Kinesis, if you come off of Kinesis and you just run Kafka on top of EC2, it's going to be a lot cheaper for you. Now, this becomes a question. The question is, do you devote engineering and DevOps time to actually go out and create and run Kafka yourself and manage it yourself? Or do you bring in a partner who can give you a managed Kafka service on top of EC2 in your AWS environment and charge you to manage Kafka, and it still be a quasi black box to you? So there's a lot of examples of these things. What's another example? CycloDB, for instance, a phenomenal database. API compatible replacements to a lot, to different managed databases within AWS, right? Like, you can run MySQL yourself. You can run it via managed service. You can run up PostgreSQL yourself. You can run it via managed service. That trend, of course, comes from like black box managed service down into managed service with a partner, down to managed service with yourself, right? We're moving, as a CTO said to me once upon a time, I want to get closer to the metal, right? Up here, lots of stacks of margin built into it that you're paying for. As you come down closer and closer and closer, you eradicate those things, but you have to, it's a scale, right? And it's not one for one. Not like for every $1 you remove here, you spend $1 over here in management. It's a order of magnitudes, right? As this decreases, this one kind of slowly comes up. So again, you can do this yourself, or you can do it with a partner, and then leverage that you can get out of a partner and out of an MSP to manage these things might be, it's worth your while to talk about it. Let's just put it that way. Things that you have to do. So here's another one that you can do without engineering. You can use a SaaS tool to help you auto size your instances. And this is a profiling. Hey, you're buying this many of this size instance, and looking at the performance optimization, utilization of these instances, you should, instead of buying that instance, you should buy this other instance. So there's a lot of interesting intelligence and things that you can do about that. Like, did you size your instances properly from the first place? There's tools that can auto shut down unused instances. Commonly marketed towards like development environments, staging and QA environments, test environments, things that don't actually run your production application, but have to run during the day, but maybe don't have to run over the weekend. If you can eradicate 4 weekends a month, so 8 out of 30 days, that has a financial impact to you as you start, scaling that up over the course of the year. If you can shut things down at night, does that impact, your finance, right? So if you go 8 days out of 30 just on the weekends, but then you say, okay, my team only works 10 hours a day, so we've got another 14 hours a day that we can turn this stuff off, right? You can see where we're going with this. Some of these tools will help you find and unattached EBS volumes, for instance. And surprisingly, boy, there's a lot in environments. If you're firing up EBS and you destroy EC2 instances and you don't have a way of reclaiming or destroying that EBS as part of that EC2 instance going away, chances are you've got a lot of EBS volumes that are unattached, and running some sort of tool to go out and find them and kill them for you, lots of money. Okay, so these are all like non-engineering stuff. Now we get into the engineering stuff. And these are the things like if you did a lift and shift of your application and you took a on-premise application to the cloud, it's not cloud native. What does that even mean? What that means from the cloud vendors, they want you to be using serverless tools, and in AWS, they want you on Lambda, and they want you on, a modern stack. And maybe that's good for your application. Maybe it's not. There is a lot of inherent lock-in when you go all the way serverless. It's maybe not a great idea for you. Containers are phenomenal for that because you still have portability of your application between clouds as long as you're not dependent on specific managed services from that cloud. So, if Google has an alternative to RDS, they have an alternative to Dynamo. They're different. I mean, in the RDS world, like MySQL is MySQL for the most part. Dynamo versus Bigtable are different. That's just some realities, right? Going through an architecture review and application modernization, this becomes a big engineering lift and shift. And depending on the application and your engineering team, again, you can find partners and you can find a third party to help you go through that process and do that work for you. And maybe it's something that you have to run that you're not really investing in strategically, but if you address and you make some changes to, and you containerize that application, it's going to give you a lot of benefits. So maybe you bring in a third party in to actually do that work for you and deliver you a containerized environment at the end of the day. So that's another example. But usually when you start talking about these things, it's a lot of engineering time. Data, the way data flows around in your environment, oh boy, you should really take when I say take a fine-tooth comb to this, find a whiteboard or a really big piece of paper and start drawing it. I have seen environments that take and internet to load balancer to EC2 instances to load balancer to Kinesis pipeline to load balancer to Lambda gateways, back to load balancer, back to other EC2 instances, back to Dynamo, back to, and then to a Lambda firing off. It sounds like I'm making this up, but I'm really not. Looking at that architecture and how that data is flowing, data is expensive in cloud. Moving data is expensive in cloud. And figuring out how your data is moving around inside of that cloud environment, managed NAT gateways. Geez Louise, you want to talk about a waste of money. If you're using managed NAT gateways, figure out how to not use managed NAT gateways. That's going to save you a small fortune. Figure out how to use Glacier when you're using S3 and having tiering on your storage. Make sure you're setting TTLs in DynamoDB if you're not. All these things, like data and the movement of data, becomes you don't think about it. People don't think about it. They think about instance cost and instance sizing, how much they're spending in EC2. Maybe they think about what they're spending in their S3 buckets, but like actually moving data in and out of the cloud and between cloud services and between AZs and regions and stuff like that. It's crazy. It's crazy what AWS charges for this. Let's see, what else do I want to talk about here within AWS? The idea of multi-cloud is interesting. It maybe makes sense for you or maybe doesn't. Our large AWS customers almost always end up with machine learning pipelines within Google. Maybe it's BigQuery, Bigtable for data warehouse and analytics, and then maybe it's TensorFlow. It's very situational, again, whether or not the cost of moving data out of AWS and putting it into GCP, depending on the size of it, what that works for you. I'll also tell you that I've had a lot of customers get into trouble with EDPs where they've had to abandon their Google infrastructure and bring it back into AWS and spend a lot of engineering hours to bring that application back and shift from Bigtable to Redshift or whatever they were doing because they hit a EDP spending shortfall. That's a big trap you don't want to walk into. Bare metal, colocation are the ultimate expressions of like saving money on cloud. This sounds crazy because of course it's not cloud, but if you have an application, and most applications hit a steady state, there's only a few Amazon.coms running Black Friday sales, right? And by the way, you can still have an application running in a data center and you can still use an AWS for elasticity and for capacity. And this is not a scary thing. And you can use the same tools. You can use Terraform, you can use CloudFormation, you can use, you can have an ALB and EC2, an AWS directing traffic between your bare metal or co-located infrastructure and AWS. And there's lots of different ways to skin this cat depending on what you're trying to achieve. I will tell you, if you have a generic containerized application serving traffic to the internet and you're running EKS, and you look at that application running in AWS, and you look at that application running on, let's go out and say we bought Server Micro, Dell servers, or whatever it is, and you put it into a data center. The cost differential between AWS and your equipment that you purchased and put into a data center is 87%. So if you're spending $100,000 a month in AWS, you'll spend $13,000 a month in a data center. Now, of course, this makes most sense if it was like $1 million a month in AWS, and now you're going to spend $130,000 a month in a data center, right? Like that's a huge delta, and that's worth the engineering time. You're going to save $800,000 a month. Go hire some engineers and go make this transition happen, right? Math that we see going from data centers to bare metal, where you don't buy the equipment, somebody else operates the equipment. Maybe they give you a managed Kubernetes, or they give you Terraform APIs to maintain this environment. You don't have to worry about like going out and buying servers and signing a co-location agreement, managing bandwidth, or bringing a partner in for that. And you're just going to have boxes sitting somewhere. It's an interesting euphemism. So if you're spending $1 million, you're going to save $720,000 a month going from data center from AWS to your own data center, or going to a bare metal provider. Now, look, there's a lot of caveats on that. And so there's a lot of, again, it depends on everything. If your application fits that mold and you can do it, it is more than likely worth the effort and energy for you to make. Because just think about that. Think about that in terms of your cost structure and your financial stack. Like, what do you spend? What is your overhead to deliver your application for your business to function? Now eradicate 70% of that cost and tell me what that does for your business. Lots of really wonderful things is the answer to that one. So there's no one-size-fits-all answer to this question of how do you save money in AWS. It is so situationally dependent on what you're running, where you're running it, what your capacity is, how do you take advantage of these different programs? Can you bring in a partner? Can you not bring in a partner? Do you have engineering resources? Do you not have engineering resources? What kind of timelines are you working with? What kind of pressure are you under? Anybody that's giving you a promise of one size fits all is lying to you. Don't believe them. Run away, run away, run away. But if this is something you like to chat about, I love having this conversation. It's always interesting to get into the bowels of an AWS platform and really talk with companies about what they're doing, how they're doing it, and what tweaks they can make to their platform to do what they actually want to do, which is just win, dominate their market, grow, be more successful, generate more profit, cut their burn, whatever phrasing you want to use, it's all available to you. And the trick is just whether or not, again, no engineering time, no engineering time with partners, no engineering time without partners, yada, yada, yada. There's some scale that you're going to go up and down. I'm Max Clark. It's a, quick rant on saving money on your AWS bills in the cloud. Hope it helps.